Hello everyone, welcome to my channel Learn Math. In this session, we are going to discuss the symmetric functions of roots of a quadratic equation. Standard form of a quadratic equation is ax square plus bx plus c is equal to 0. And let's say alpha and beta are roots of this quadratic equation. Quadratic equation. Then functions of roots, that will be alpha plus beta is a function. Any operation between the two will be called function of alpha and beta. The operation may be a summation, it may be subtraction like alpha minus beta or beta minus alpha. It may be squaring the roots, it may be summation of the squares, or any other operation which is performed on these roots alpha and beta, that will be function of the square roots. Now what is the symmetric function? Symmetric functions are those functions in which if the symmetric functions are those functions in which if the variables, now these are the coefficients, but for a function these will be considered as variables that can take values, different values. So a symmetric function is a function in which if the variables are interchanged, the value of the function remains the same, then that function will be called a symmetric function. Remains the same. Now, for example, we have the coefficients which are alpha. So, alpha plus beta will equal to beta plus alpha. We are interchanging its positions. We have interchanged alpha will be beta and beta interchange with alpha. The result will remain the same. Similarly, alpha minus beta and beta minus alpha, these are not symmetric functions. The value will change if we interchange the variables. Similarly, alpha square plus beta square will be the same if we write as beta square plus alpha square. So we are considering the symmetric functions of alpha and beta in this session. So the first function that is symmetric for the coefficients alpha and beta is alpha plus beta. Similarly, the second function which is symmetric for both is alpha multiplied with beta. The third function which is symmetric for alpha and beta is alpha square plus beta square. Now we know that the summation of roots of a quadratic equation is equal to minus b by a. Now this function is in terms of the coefficients a and b. So we are writing alpha plus beta, it is a function of the roots of the quadratic equation, and now we are writing it in terms of the coefficient which is minus b by a, because this is sum of roots, and we know that sum of roots is equal to b by a. Similarly, alpha beta function is product of the roots, which we know that is equal to c by a, because this is product of roots. Now we will find alpha square plus beta square in terms of the coefficients. So alpha square plus beta square can be written as alpha square plus beta square, and we are going to add 2 alpha beta and subtract 2 alpha beta from alpha square plus beta square. This 2 alpha beta minus 2 alpha beta cancels out and that will equal to 0. But by adding and subtracting, we are completing the a plus b whole square formula. So therefore, a square plus b square plus 2ab is equal to a plus b whole square. So we can write that alpha square plus beta square is equal to, now this is a square b square plus 2ab, so we can write as alpha plus beta whole square minus 2 alpha beta. Now this is sum of the roots and this is product of the roots. So sum of the roots is minus b by a taking whole square, and product of the roots alpha beta is c by a. So we can write that alpha square plus beta square is equal to minus b square, minus multiplied with minus will be minus, and b square is b square. Similarly, we have a square minus 2c by a. Now a square is LCM. A square divided by a square is 1. 1 multiplied with b square is b square. A square divided by a is a multiplied with 2c is 2ac. So we can write that value of alpha square plus beta square is equal to minus b square minus 2ac divided by a square. This is the function of roots in terms of the coefficients. Now, another symmetric function of the roots is alpha cube plus beta cube, and we can write it as a cube plus b cube is equal to alpha plus beta cube minus 3 alpha beta into alpha plus beta. How we have written this? Because we know that a cube minus b cube is equal to a plus b whole cube minus 3ab into a plus b. So now alpha plus beta, alpha plus beta is equal to minus b by a whole cube minus 3 alpha into beta is equal to c by a, and alpha plus beta is equal to minus b by a. So we have minus b cube divided by a cube minus 3 multiplied with c is 3 multiplied with minus b. This will become plus, and we have 3bc, and a multiplied with a is a square. Now a cube is LCM, and a cube divided by a cube is 1, so we have minus b cube plus a cube divided by a square is a, and a multiplied with 3bc will be 3abc. So the value of alpha cube plus beta cube is equal to minus b cube plus 3abc divided by a cube. This is alpha cube plus beta cube. This symmetric function is in terms of coefficients a, b, and c. We can write this alpha cube plus beta cube is equal to, rearranging the right hand side, we have 3abc minus b cube divided by a cube. Now the other function, that is symmetrical, let's say this is function number 5, and that is 1 over alpha plus 1 over beta. Now LCM of alpha and beta will be alpha beta, and this alpha beta divided by alpha will be beta, plus alpha beta divided by beta is alpha. So we can write that alpha plus beta divided by alpha beta. Now we know that alpha beta is the sum of the roots, which is equal to minus b by a, and divided by alpha beta is product of the roots, which is equal to c by a. So this can be written the minus b by a multiplied by a by c. A cancels out with a, and we have minus b divided by c. So 1 over alpha plus 1 over beta is equal to minus b by c. The other symmetric function of the roots of quadratic equation is 1 over alpha square plus 1 over beta square. Now LCM is alpha square beta square, and alpha square beta square divided by alpha square is beta square, plus alpha square beta square divided by beta square is alpha square. So we can write that alpha square plus beta square divided by alpha beta, and we can write it is whole square. Now similarly to the alpha square beta square, we will add 2 alpha beta and we will subtract 2 alpha beta to make it a whole. So 1 over alpha square plus 1 over beta square is equal to alpha plus beta whole square and minus 2 alpha beta divided by alpha beta whole square. We have applied the a square plus b square plus 2ab is equal to a plus b whole square formula. Now we know that sum of the roots is equal to minus b by a, and product of the roots is equal to c by a divided by, and product of the roots is c by a whole square. So this can be written as minus b square is b square divided by a square and minus 2ca, and this we can write as divided by, this will be c square and this will be a square. So we have a square is LCM, a square divided by a square is 1, 1 multiplied with b square is b square, a square divided by a is a, multiplied with 2c is 2ac, and this division when converted into multiplication, the terms will get reciprocal. Now a square cancels out with a square, so we have b square minus 2ac divided by c square. So the value of 1 over alpha square plus 1 over beta square in terms of the coefficients is b square minus 2ac divided by c square. Hopefully this is easy to understand. If you find the video helpful, please like the video, subscribe the channel and press the bell icon so that you can get notified when a math problem is solved. Thank you.